If, in the last example, you were asked to find the third term in the expansion of x squared plus 4 to the third power, you could expand the whole thing like we did and say, well, this is the first term, this is the second term, this is the third term, this is the fourth term. So here is the third term. And that works. Or you could take the shortcut. Instead of having to expand this all out, well, that wasn't so bad if n is 3, so we have 4 terms. It's not that much work, but what if I did 30 there? Then you'd be finding 31 terms and then having to count over. That's a real bummer. So what we can do is the same problem using NCR, NCR times the first x to the n minus r, y to the r. And this is in the expansion of x plus y to the nth power, where x represents the first term and y represents the second term. Notice NCR, whatever is our r, will have a great connection with the exponent of our second term. And these two terms will have to add up to n. So this plus this will equal n. That's what this n minus r and r relationship show. So when we are asked to find the third term of x squared plus 4 to the third power, notice our given first term is x squared and our second term is 4. So if I'm using this formula, remember what we did to find our coefficients. The coefficients, if our power is to the third power, the coefficients were 3c0, 3c1, 3c2, 3c3. In fact, our third term will be 3c2. It's always going to be one less than you would guess. Of course, if they asked you to find the third term, you would guess that the r would be 3. But because we started counting with 0, our third term, you can see, is going to be with an r. When I say r, I'm talking about NCR of 2. So our first term is x squared, and our second term is 4. Substituting in for our first term is x squared, because that's what was given, and instead of y, we have 4. Remember, whatever is here is going to go here, and these two have to add up to n, which is 3. So that must be 1, or you could use n minus r. 3 minus 2 is 1. So now I have this, which is, of course, this is 2 times 1 if I'm using my shortcut, and 3 times 2. X squared to the first is x squared, and 4 squared is 16. 2's cancel. 16 times 3 is 48 x squared. And I get what I knew I should have gotten by using this formula. And I think the hardest part of this is to figure out what r is. If I'm looking for the third term, r will be 2. If I'm looking for the 10th term, r will be 9. If I'm looking for the 44th term, r will be 43. Why? Again, because we start counting with 0. Find the 6th term of the expansion of a plus 2b to the x. Now, this is taking the form x plus y to the n, where playing the role of our first term today is a, and playing the role of our second term today is 2b, and n is 8. Now, if n is 8, I know there is n plus 1, or 9 terms. If you want to expand this all out, getting all 9 terms, and then count over 1, 2, 3, 4, 5, 6, and circle that, be my guest, that will give you the answer. It's just not very efficient. I do know that for the expansion of x plus y to the n, the specific term can be found by using NCR x, the first term, to the n minus r, y to the r. Whatever's here goes here, and these two have to add up to whatever n is. The sixth term, now watch my fingers, I'm going to find the sixth term. That is, n is 8. 8C0, 8C1, 8C2, 8C3, 8C4, 8C5. That's the critical part to this, is that if we're using this, it's going to be 8C5. And I know that's very uncomfortable with some people. They say, well, but we're supposed to find the sixth term. Why are you finding R5? Well, because I started counting with R equals 0. The sixth term will actually be 5 there. First term, A. Second term, 2B. Playing the role of X today is A. Playing the role of Y today is 2B. Now, whatever goes here, I know I've got this great connection. It's going to go here. And these two have to add up to 8. So 8 minus 5 is 3. These two they add up to whatever my n was. When I expand this out, I use my shortcut. 5 times 4 times 3 times 2 times 1. Whatever my r was, I use that as factorial. Now I'm limited to 5 terms. 8 times 7 times 6 times 5 times 4. Can I cancel? Of course I can. I will do that in just a moment. This is a to the third power. And of course, this is 2 to the fifth, b to the fifth. And I have to know 2 to the fifth is 32. So I have 32b to the fifth ready to go, multiplying by whatever this is. Now here, 3 times 2 will cancel with 6. 5 will cancel with 5. 4 with 4. 8 times 7. I get 56 times 32 times a cubed times b to the fifth, which will give me 1792 a to the third, b to the fifth. Look how much more efficient I was. Rather than to find all the terms and then circle the sixth term, I can just use this formula for this expansion by plugging and chugging. The key is the sixth term will have an r value 1 less, 5. Here is a great example of the benefits of using in the expansion of x plus y to the n, using NCR x to the n minus r, y to the r to find any term. The problem says find the coefficient of the term a to the 6th, b to the 5th in the expansion of 2a minus 5b to the 11th. Now, as soon as I see 11, I know 11 plus 1, there are 12 terms. So if you want to, you could expand this out, find all 12 terms, and then look for the one that has a to the 6th, b to the 5th. That would be the most inefficient way to do it, but you could do it that way. I'd much rather use this and say, well, playing the role of x today is 2a, and playing the role of y today is 2b. So n here is 11. I know this is 11c something. My first term is 2a. My second term is negative 5b. Now, I am looking for the term b to the 5th. If this is to the 5th power, because I eventually want to have b to the 5th power, then this has to be 5 as well. Because I have this connection with my formula. Whatever's here is going to wind up here. So if this has to be 5, this has to be 5. Now, these two exponents, whatever's outside the parentheses here and here, have to add up to whatever n is. Or you could say it's n minus r. 11 minus 5 is 6. You can see 5 plus 6 does give us 11. Now it's time to crunch in our calculator. 11c5 is 462. 2 to the 6th power is 64a to the 6th. Negative 5 to the 5th, that's going to give us a negative answer. 5 to the 5th is 3125b to the 5th. And of course, this is going to give us a to the 6th, b to the 5th. When I multiply a negative times a positive, I get a negative. And 462 times 64 times 3125 is going to give me negative 92,400,000. So the question is, what is the coefficient? Well, there is our coefficient, negative 92,400,000.